everybody. It is Mike Levin, Poconos Pythonista. And so it begins today, another new day. It is Saturday, January 23rd, 2021. Mad Max. Anyway, I'm here in my urban assault vehicle, and I am heading out on a drive, and I'll be at it for a while. So video time. I figure I've been so comfortable with making these videos over the years, and I've seen the trend of so many people hopping on the live bandwagon to do gaming and such. The Twitch movement, the YouTube live movement, for which I qualify. I have whatever that is, 1,000, 10,000 viewers, whatever, where I can do YouTube live streaming. However, I have decided how to divvy out my energies, and most of it goes to either my day job, which I love and is often the topic of discussion here, or it goes into family and relaxation and just enjoying life in a very low-key way. I am more an introvert than an extrovert on the scale. And even though I'm very comfortable being with people, being around people, definitely I like my own company very much, and I am one of those folks who's very happy to live inside my head, or to live inside the head of others in long-form reading. I am a reader. I am, once again, for the third time in my life, restarting the Dune series. I'm on just book one of the series, but with a new movie coming out, I want it to be fresh on my mind. And Dune has been very meaningful in my life, and has been a useful lens through which to look at the world and to adjust my own world perception. It has a lot of stuff packed in there, starting with like maybe the first 3 books, which were Frank Herbert's real direct writing creations, and then later on with other stuff that was written by his son and a co-writer, which explores more of why the Dune world is the way it is, with no robots, no machines made in the image of humans' minds. So that's a really big tenet of the Dune world, which means it took them something to get to that point. And we only join in the world once it's all, no artificial intelligence rules across the galactic empire. And we don't get much of the backstory as to why it got that way. The books written by Frank Herbert's son and the co-writer cover all that time, and there are so many of them. You can just keep reading and reading. I forget if there's like 16 or 20 books in the series. There's a lot more than you think. The Sisterhood, the Mentats, other parts of Paul Atreides' adventures. So if this movie is any good, Dune is going to be back into pop culture again, and I would like to brush up on it in my head, because there are so many good key concepts to life sprinkled throughout the book, not the least of which the gom jabber box needle exercise that's right at the beginning of the book. It's no spoiler, because it opens up, testing young Paul Atreides, the Sisterhood, making sure that he's cut out to be the leader of people. Okay, so sorry if that's a spoiler for anybody, but it's good to have a little bit of exposition like that. And you stick your hand in this box, and you know that the pain isn't real. I think, at least in Paul's case, he knew it was. And if you pull your hand out of the box, you're less than human. If you can keep your hand in the box and do mind over matter, control your inner animal self, then the Sisterhood considered you enough human to be a ruler of people, because you cannot be a slave to your animal passions. It's just no good for humanity, as we've seen lately. Lizard brains should not be in control. If everything you do is to justify the lower order animal parts of our layered up brain, then you're not really self-aware in that Maslow self-actualization pyramid way. You might think you are and have the game down so well, but a fairly static thinker in a static game, carrying out the things that they know works over and over, driving up their personal riches and empire, is not the sign of a self-actualized person necessarily. It's the sign of an effective hunter, a sign of an effective, as I've talked about in previous videos, green arrow type. So the world of people generally splits down between the softer elements, the round, the blue, the earth stuff, the gathering part of hunter-gathering, the knowledge and, non-linear thinking part of the humanity equation. And then the others split down the middle to the other side, which is the green, the sharp, the linear, the oftentimes competitive and tightly contested and known rules, the hunter folks, the people who take up technical things with, masterable rules, and where craftsmanship exists because you can always be hyper competitive and master your craft and be at the peak of your game. That appeals to the green arrow types. And, it generally is the yin-yang split as well, with the yin being the rounder and softer and stormier and non-linear, often where surprises come from, where the real advancement in society comes from, the yin type thinkers. And yang generally is the green arrow type, the male, the masculine, the hunters, the logical and clear thinking, although logic and clear thinking is all about labels and pigeonholing actual reality into a world of symbols and labels that does not truly fully represent reality. Reality is all that can fully represent reality, which is why, determinism is not a thing that should turn you into a anarchist. It's not anarchist, it's a nihilist. Many lines of thinking, especially when there's so many things around us that fit into the apocalypse is upon us thought pattern, has to be, offset by the fact that we're living in an awesome time where magic is becoming real, and we have really managed it much better than many of the things in sci-fi have, led us to fear would happen. We blew past 1984. We're now blowing past Mad Max. And these apocalyptic visions just keep not coming true because we as a society, as an animal, as an organism, live on the vibrating edge. Things are almost always just on the edge of disaster and ruin. It's always been that way. There's always been the threat of major setbacks and the occasional actual major setbacks, like who knows how many times before recorded history really kicked in. But then once recorded history kicked in, the loss of the Library of Alexandria, the Dark Ages, there's always things that sets humanity back here and there. There's stories from the fossil record about how the Homo sapiens, when it was like 5,000, it got cut back to like 40 and expanded out or something like that. I forget exactly the details, but our branch that became the main composition of us, because we are a composite of multiple branches, including the Neanderthals and the Devonians, I think it is. I forget the name of that other one. There's a few branches that seem to have become separate species, but apparently not really, because they can interbreed, so they're not separate species. But we think of them as things like Neanderthal, which is really a lot of the white-skinned Northern European folks coming down from where it's cold. It's not really that hard to figure out some viable cancer, and it got, different amounts of skin melatonin or whatever it is in their skin that accounts for the darkness to resist the higher, ultraviolet rays and stuff from the sun that you get. And those who hung out on the north and got pasty, and then they came back together as the ice age receded. And, statistics, determined, which genetic base became more prevalent, what we call Homo sapiens, and which became less prevalent, what we call Neanderthal and those other branches. But we are an interesting composite mix, and we are bubbles that splashed out of the ocean, anti-bubbles. If you think about a bubble in the air, a thin film surrounding air, and because of air pressure, it reaches that perfect, magical, neutral, stable position for a bit. The same thing happens when water splashes up. Those splashes become little water droplets or droplets of whatever liquid, and then sometimes when they come down and they hit the surface, because of the surface tension of that droplet, it doesn't absorb back into the ocean. It has a boundary, a shell, because of magnetism, a miraculous thing about our world. Now that is called an anti-bubble, and we are contained water that came out of the ocean. It just happens to be according to a system that, can make more bubbles like itself. And do the recombining of DNA trick, sex, definitely accelerates the experimental process of life. These are realizations that are kind of weird to have, but sex is not necessarily a prerequisite of life. There's plenty of examples of plant and animal life that are asexual. That is, they split to divide. They split like cell division to recreate, but just sometimes they don't split and recombine into the original body. They go their separate ways. Another magical moment. However, they tend to be genetic clones of each other, and so somewhere along the line, some miraculous life hack happens that probably happens on other planets and other analogous situations to Earth, where they go, hey, if we just, mix things up a little bit between two separate creatures that might have differences, then the resulting creature might have new traits that are advantageous. It might have traits that destroy it, but at least you're in the game. At least you're taking a risk. And that decision of life to take a risk by giving up at least half of itself to make something new that is better suited for survival and winning in the game is a profound, amazing thing. And so much about our existence, our human existence, animal and flowering plant existence in general is determined by that contest. And it deeply colors our perceptions in ways we don't know necessarily. And when we become these higher form, incredibly generalized, abstract beings that live on the vibrating edge of everything, vibrating edge between hunters and gatherers, the vibrating edge between having to be meat eaters and being perfectly able to live without eating meat, between violent and peaceful, between believing that people are basically good at heart, where they live and let live attitude, versus people are always looking to get one over on each other, because in the end it's a dog-eat-dog world. So the reason we live on the vibrating edge here is because these questions have not fully been answered yet. So the vegetarians will raise arms going, of course they have. And in the long term, they have. There's so many reasons that not eating meat or eating artificial meat that's made through some production technique. By the way, the new Star Trek, yay to that Starfleet admiral who made that comment about eating the replicator, output, and they'd rather do that than the atrocities of eating real apples. It had to do with eating a certain thing that comes out of your body, and how when you think about it, how disgusting that is, versus no, that is the noble way, because we don't have to enslave races or whatever, take over planets that have apples to eat an apple. So I'm one of these optimists who's like, in the end, technology does usually prevail. It wins out. It brings solutions that reduce suffering and allow the vibrating edge value proposition to change, to shift to new normals, usually towards greater free time and luxury, and moving more towards the life of a cat, ambush predators who work efficiently by cramming all their effort into a smaller time period at something that they're really good and specialized and well crafted at, hunting, so that they can spend 23 hours of the day just lounging around. So that is contrary to what a lot of folks think of as winners and achievers these days, that spend all their time working on the next big thing, caught in an almost addictive, obsessive, secular process of empire building. Your Elon Musks, your Jeff Bezoses of the world. To some extent, you're Bill Gates, but a lot of people chill out in their old age, and that's what Bill Gates has done, giving it a lot of his money to foundations and really working on causes, catching a lot of heat for it from the conspiracy nuts. But sometimes you gotta take your foot off the acceleration, off the gas pedal, and stop and think about what's really important, what it's all about. And occasionally you do have a chilling out moment. I was very pleased, another spoiler, I don't want to do spoiler like the Frozen kiss for people who haven't seen Frozen yet. Everyone's seen it and they know it's the kiss of family love as opposed to romantic love. But the movie Soul, the latest Pixar movie, really has its moment about the main character. I forget, I think he might have been 21 or something, but basically every soul that enters this world has a number, and they increment the number with every baby. And this is about one early on in the process that resisted wanting to come to this material world because it had nothing that appealed to it here. It only saw the pain and suffering, and all the mentors that it had to teach it the great ways of the world leaned towards the Einstein and great achievers, Alexander the Greats of the world, who were obsessive achievers for all the days on this world, which are often cut short by the nature of their obsessiveness. And they get into that amongst ordinary people as well, when things like collecting, if you get the collecting bug and you collect too many things and it dominates your life, what happens to your soul? Even though in so many other ways that sort of focus seems like a good thing. We call it the zone or the flow, which is so critical to artists who are creating. And it was one of the first movies that I really saw deal with the vibrating edge question of life and existence. While yes, there is the alpha and the omega game always going on, there's always the newest, the greatest, the best, the often most secret and often most insider, because those people don't necessarily want to share the fruits of their labors, things going on in this world. The elite of the elite, the coolest of the cool, and the so secret that you don't know they exist. They're out there. It's statistically very small portion, trust me. The kind of personalities who feed their hunger, all the things they need, in those situations are either very few or very tormented souls. So don't envy not being the greatest of all insiders. Those people have given up so much of themselves and so much of the satisfaction of everyday life that, if they draw pleasure out of being those people, great. More power to them. We need those folks to make those sacrifices of them so that we don't have to worry about those things quite so much. Now, of course, they are to be worried about. These things are always going on in the world. We're always on the edge of some sort of disaster. However, our species has consistently proven its mastery of brinksmanship, pulling back from the edge. I forget which general or leader used to talk about that. It might have been Eisenhower as a general and then later a president, Dwight D. Eisenhower, I believe, where you go right up to the edge and you challenge your opponent to engage you. And you go right to the edge of the war or battle or engagement, and you challenge the other to step down. And if they do step down, then you have had a win without having a war. It is yet another interpretation of the samurai way, which is that to have some better mastery of a craft, I guess it's statesmanship in that situation, you can avoid having lots of people get killed in more traditional, tribal battles, but scaled up to national levels, which is just terrible. Nobody wants that. So the modern ways, the modern tools, the modern capabilities make so much at stake that we find new ways to not fully engage for fear of going over the brink, of going too much to one extreme or the other in the vibrating edge. Now, this vibrating edge, I first became aware of it as such a real existing thing, easily demonstrated in nature, is when I switched from mechanical engineering at Drexel University to graphic design. I became an art person, which I ultimately switched out of because art is so darn subjective, and it's really better to live in some objectively, some objective world where everyone can look at a result and agree that it's good. Now, that's because I was not so much of a risk taker and I was too sensitive of a personality to be in the graphic design field. Talk about some of that Maslow self-awareness thing. I'm a blue circle. I am a total blue circle by nature. But through the nature of the times I grew up in, the 70s, the 80s, I was born in 1970. I am 50 years old. And being a product of that strange, Father Knows Best reruns, Leave It to Beaver, Brady Bunch kind of world, I have a very post-World War II, New Deal, GI Bill, American dream, suburban dream view of things. A form of brainwashing. I moved to New York. I lived there for about 15 years, worked professionally, still work professionally in New York City, even though I now moved. You go where the jobs are, but now technology has changed all that. There's no going back to the way it was before lockdown and quarantine. We are in a new world. One in which the jobs can be one place and the people doing the work can be somewhere else. Virtual teams really working, and different classes of people coming into existence. I'm sorry to say, but it's very much like one of my sci-fi, well, I don't know if I want to say favorites, but one of the sci-fi greats, I believe it was Snow Crash, one of the early Neil Stephenson books about the emergence of artificial intelligence. And everyone was divided into either pizza delivery people or knowledge workers. I don't think he called them knowledge workers, but people who jumped into cyberspace in the grid and did some sort of intellectual product work or entertainment or any of the other things that could be delivered electronically with telesenses, everything. Because in that scenario, you plugged in all your senses, recordable, playbackable, simulatable, taking over other people's minds and stuff, because of that machine-mind interface made all kinds of stuff possible. And so most people jacked in and lived in that cyberspace. A few people lived in flatland. This has colored my perceptions immensely. Flatland was reserved for the few remaining feds and federal workers. They lived in flatland, where there was a lot of Excel-like work, rows and columns, such as it were. You see me smiling because people who listen to me a lot might know where I'm going with all of this. And the jacked-in world was a lot like Doom and Quake and, all the stuff that later evolved into Fortnite and World of Warcraft, Second Life, and all these intensely immersive games that can swallow you up. And I see parts of other sci-fi in that. The humanity split between those who plug in and go online and become part of some new humanity that becomes dependent on a technology, and those who stay on the surface or don't use the machine interface quite so directly, who become part of the old school branch of humanity that continues to exist and serve a different purpose. I really see the 3D immersive VR, and to some degree, but less so, augmented reality technologies as a case of this, and I have resisted and I have stayed in flatland, even though I consider myself very high-tech, and will dabble in the other stuff to see what it's all about, but then to affirm my views, and though this is too addictive to me, this is my crack or whatever, then back off out of the 3D worlds. And occasionally I allow myself to get those addictions. The last I kind of clearly remember was Sim City and Populous on the Amiga computer. Those were as immersive as I needed to get. And of late, Animal Crossing on the Nintendo Switch Lite. And I am, and so much of the world is predisposed to addictive, to allow so much of my time to be gobbled up by that. And I have resisted, and I have stayed in flatland, which has become Linux, Python, Vim, and Git, much of what I am promoting here, and as an interface, as a way to interact with the world, as a way to express yourself, languages to work in. And I guess a lot of this talk comes back around to tools. Taking up tools really does color how you see the world. Speaking in a language, the details of that spoken language color a lot of how you see the world, because when you stop to think clearly and you talk things out, you're using the tool and you're coloring your perception with all the characteristics and nuances that is the English spoken language, in my case. The same applies with machine languages and programming languages. Context is also a thing. When you speak English, you can speak to a lot of people. When you speak C, Python, JavaScript, you can talk to a lot of machines. Now, when you want to talk to both machines and people, I say there's Python. And I say Python is different from anything that came before it, even ABC upon which it was based, because everything Unix is to some degree derivative of Multics, the corporate version that came before it but was so overweight. The bad boys come along and they do the 80-20 rule. Bam, you got Unix. That's done in the late 60s. In 1970, it becomes real in the halls of AT&T, Bell Labs at the time, BSD. So Bell Labs, it leaked. A East Coast thing became a West Coast thing. And Berkeley system distribution became a thing. So Unix got out in the wild. And now lots of hardware could be made to run lots of software. The information age was born. It was burdened by lots of intellectual property issues that continue to this day in the form of the SCO lawsuits. Lots of companies got dragged in, including Novell. And a lot of great people and ideas died on the altar of intellectual property at the time because it became inconsequential, as both Linux was created by Linus Torvalds as part of a summer project that brought much of the benefits of Unix to the world, plus a very free and open source mentality, an enforced free and open source mentality. In fact, there were splits between the Free Software Foundation at this time that believes that all software should be free, and the free and open source software people who believed that open source should be able to be used in proprietary for-profit products, so long as the contributions you make, not necessarily the proprietary code bits of your own product, but the advancements you make are contributed back. And this has been enforced in a few cases where companies have tried to not contribute back. In the case of Linksys, that's where OpenWRT comes from, and one of the packages under the interesting Debian pioneered licensing model, because not all licensing models that enforce the free and open source value proposition are equal. There's very liberal ones like the MIT one that does not so much enforce it, saying just use this however you like, embed it into for-profit products, I don't care, alter it however you like, keep what you do secret. And the GNU licenses, GNU version 2, under which so much stuff is still kept, in GNU license version 3, which forces other types of give-back concessions, which a lot of people think are wrong. Why be forced to give back your proprietary bits when you took the free and open source and you embed it into your project and you go, hey, that's okay, that's GNU version 3. And I think TiVo used that and people tried to call them out on it. I forget how that concluded exactly. But licensing is a big deal. So Unix was very tightly controlled licensing for the profit of companies like AT&T until Berkeley system distribution got out of the bag and became a rebel illegal version getting out there. And at the same time as Linus Torvalds was creating Linux, a black box engineered version of Unix, not really a version of Unix, there's some language issues there, but a reverse engineered black boxed compatible product of Linux. And the free BSD project, which was blackboxing Unix itself. So that still went on to become a type of ivory tower, tightly regulated. This is Unix because this organization says so, official stamp, and anything goes. Linus Torvalds branch of Linux, which broke off into many different branches that we know in today's products that we're very familiar with. The Berkeley branch has really evolved into Macintosh and the iOS platform, at least the boot kernel that gets it started, and then all the graphical stuff is taken over by Cocoa and iOS and other things that just to put the candy wrapping over the underlying system. Apple calls their version Darwin, which is a branch of the Berkeley Unix, which has, I believe, what's called the mock kernel in it. And it's a different boot kernel. It has different, drivers that it works with, and different intimate knowledge of the hardware that it works with, because Unix and Linux are actually much more low-level things than people think. They're just the low-level boot kernel stuff, the Frankenstein moment of getting the hardware, getting the heart beating in the hardware. And then it rapidly turns control over to other things, systemd these days, or other initd processes that still are out there. In the case of Linux, Unix has its own stuff, but it's all text file based. You put text files places, and the boot process knows to look at that text file and to start executing the commands it finds there. Occasionally there are things that are not text files, but that's only because they went through a compiling process by a compiler to be turned into a binary that has much more intimate knowledge of the hardware it's going to be run on, so that binary, that .exe or that elf file, can be dropped into a particular place in memory, and because of the nature of the hardware, it can start reading from there, and it knows that stuff means a certain thing. It would be meaningless on other hardware that doesn't have the same machine instruction set. You might hear about X86 hardware versus ARM hardware. That's one of the big main differences there. They have different instruction sets that the text-based source code software is compiled into binaries and EXEs, and often drivers, because drivers, for their high performance needs and components of operating systems, need close, intimate knowledge of the hardware it's going to be run on. So compilers that make these EXEs are likewise familiar with the hardware they run on. GCC is made for X86 hardware, or is recompiled into GCC for ARM hardware. Other branches exist of Linux. It's gone down this Red Hat and IBM and generally enterprise and for-profit branch that also includes CentOS, that has been very popular for get started with free Linux on enterprise, but if you want support, you pay for it. But now everybody pays because it's gone subscription model. If you want to still be on that branch, which is the POSIX compliance stuff, because it uses RPM, the Red Hat package manager, as opposed to Debian's apt-get and Synapsys systems. So it's real subtle differences that have to do with their software repositories. But the IBM or Red Hat branch that also consists of Fedora, I believe, maybe the last free branch on the IBM Red Hat direction. There was also Mandrake. There were other versions in the past that forked their own branches. They're not as popular today. There's a few small ones that don't buy the whole bill of goods that everyone peddles now, like systemd for startup. Those would include Gentoo Linux, Slack Linux, but not a lot of people use them. TinyCore Linux, really small versions that have their own repos, and not the big massive repos of RPM that uses often Yum. That's the package distributor manager name that people encounter a lot. But the other major branch is Debian, which is also Ubuntu, which is also Microsoft, which is also Raspberry Pi, which is also a lot of cloud hosting, because Debian is Ubuntu, is Microsoft, and it's now hosted on Azure. When you want a, instance of Unix, there's not the ambiguity. On Amazon, with their EC2, Amazon Web Services, Elastic Computing Cloud, there's the choice of using AMI, their own stripped down version of Linux, as your tiny, small footprint starting point. But so many people these days will use a Ubuntu 18.04 LTS long-term stable release, We're in Ubuntu 20.04 more recently because Microsoft supports it in their default distribution of WSL, Windows Subsystem for Linux, really worth using. One of the more fun things I do that I peddle and promote, I don't peddle it because I don't make money off of it, but when you learn the old school way of doing things, when you live in flatland, you're usually learning how to open what once was a teleterm window, a teletype window from the olden days. And some people might remember the program teleterm, which is just typing back and forth to some remote computer, assuming some X by Y grid of characters that you can use. This is where 80 column, 20 or 40, depending on whether you had single or double height characters, but generally 80 columns across, 80 character widths across by 40 up and down, oftentimes 20 because of the old character heights, but 20 by 80 typing terminals. Without encryption, that was teleterm. It's still around, it's still in some machines. And if you have a direct connection without using the internet to connect, like a serial connection, a cable comes out of your control device, your terminal, your local PC, more and more your phone these days, and a wire goes into some other device, like a gaming console or a Raspberry Pi or some sort of microcomputer that you're using, an embedded computer system like an Arduino. That's a direct, often serial connection. And because it's a serial connection, you don't need the encryption. It can be an old-fashioned teleterm window. However, because so much goes on over the internet these days, that when you're talking old school and you're talking that type-in interface to another remote computer or virtual computers on yours computer, you're often using SSH, a secure shell. The SH, the SH and SSH stands for shell, so it's secure shell. And it's basically teleterm from the olden days, forcing its communication to go through encryption, encrypted protocols, secure shell. And those would be things like Bash, the one that Microsoft is peddling because it's the traditional one that comes with Ubuntu. So it's the Bash shell on the Ubuntu Linux system, on often the Windows subsystem for Linux, which is on Windows 10, which is under some sort of hypervisor, which is like an Intel-ish technology right now. But the proprietary Intel-ish of it is being removed because no one wants to be Intel dependent anymore. Everyone wants to remove their Intel dependency and go, hey, look, we can run on ARM or ARM64 too. And the main trick is controlling two things. One, controlling what your machine set is, what your machine instruction set. Whether you're using the X86 instruction set, whether you're using some version of the ARM instruction set. There's a lot of different flavors of instruction sets because not all hardware is made equal. But you choose one and then you run some sort of emulator on your obviously much more capable than just that instruction set hardware. So there's always an emulator, a virtual machine in the picture. It's never not in the picture anymore. Compilers use it as a trick because they're really compiling for not just any hardware that might exist out there, but for some predefined hardware definition. That's why you'll find virtual machine technology built into the names of so many versions of the GCC, the free and open source compiler for the Linux platform that usually compiles C and C++. I forget, it's L something, but it refers to the virtual machine technology that's built in at the compiler level. Well, it's also built into the hardware processor level because your machine instruction set is hitting that before it hits all the kooky, multi-core, excessively capable stuff that's also on your hardware. Other stories, other sub-stories there. So, all the software people make it so that you're targeting a machine instruction set, and really not even that, because your language is higher level than that and doesn't need to worry about the instruction set implementation. Everything gets compiled to an assembler machine code language from which it can further be optimized for your hardware, but everything goes to ASM first. That's why in the end, every language that's Turing complete can compile to ASM, and everything about the language you use is personal preference. So Python really isn't better than JavaScript, and JavaScript isn't really better than Python, and compiled C++ code really isn't that much better than Python or JavaScript, except insofar that you can create a compiled exe that runs slightly more optimized, inserting cases where the optimization tricks of JavaScript and Python can't step in and go, oh, we'll be as fast as C because you're using list comprehensions, and that's map reducible, and we know about multi-core somewhere in this stack and can map reduce the work, and you just go on coding in Python using your list comprehension best practices. We'll take care of all the parallelism in the background, and you get the advantages of true parallelism and not just non-blocking concurrency, which is not parallelism. That just means your code you can use a concurrent coding style. It doesn't mean your code is running as fast as your specific hardware can make it run. If you want that, use the Go language, or use Python and know what you're doing, or use Python in the Dask package and only sort of know what you're doing and use lots of list comprehension. So anyway, I digress. Do I digress? No. You think in languages. The language you think in natively, primarily, usually the first ones you learn, usually the one that controls your initial synaptic mappings, the one to which everything else is mapped, is special and more important in your mind. This is why everyone flocked off of C when they could to Java, because garbage collection, and you could get rid of heaps and stacks and pointers type things in your first learnings. If you can ignore garbage collection in your first learnings, so much more is left over in your head for design patterns and all the things that matter in acquiring your first 2 years of experience to get a job. So comp science departments around the world flocked to Java because it was C++ plus garbage collection. Multi-platform, a lot of the promises of the virtual machines were the new shiny penny, and everyone was like, oh yeah, Java, very important. A lot of things flocked over to Java in those early days that needed to solve the Y2K problem early and had money, so banks. And they didn't have enough fear to stand still. Air traffic controller and ASL, there's still a lot of, I think it's ADL, the one named after Ada Lovelace, the great language running flight traffic controllers where people feared going into the system, and not so much of a Y2K problem was present because things were implemented with ADL, which later became ALGOL, which later became C, which later became ALGOL. Yeah, ALGOL 6, which became C. It's good that abstractions were introduced in numbered versions of these things that were really pivotal steps forward and big branches in the evolution of language thought. So C language thought is a special thing that came from, at least we forget BCPL, so C, C++, Java came from C++, which came from C, which came from BCPL, which came from ALGOL 6. which did not come from ADL, but are closely interrelated. ADL comes more from a Prolog heritage, where they had to get the bugs out and could not let crashes in software crash airplanes. So that's the ADL branch that's still out there today. And Pascal, boom, I said Prolog, I take that back, Pascal and ADL. Some object-oriented perhaps introduced, a lot of keeping your code clean. So many branches, but it colors how you think. Very strong modern branch that became all things C and the C syntax. Now you would think that JavaScript came from Java, but no. Although they lifted a lot of the syntax from C because it was a popular modern language, JavaScript, Reinbach, it comes from more of a meta-language tradition of Lisp, another great language tradition. So if C is one of the great language traditions and what we might call a granddaddy language today, so is Lisp, a highly meta language, a language that is used about itself, where the data structures and the logic flow control structures are intermixed, making certain things possible in ways that many, Paul Graham of Y Combinator and Yahoo Stores, would say are not possible in any other language. So Lisp and all things that are derivative languages from it, they're directly written in Lisp, such as Clojure and Scala, are in that tradition. I would even say CSS and a lot of imperative languages. One of Lisp's favorite tricks is to write an imperative sublanguage. Imperative sublanguages are things like HTML, XML, and the whole SGML tradition. It all started from a structured graphics markup language, and it was so complete and heavyweight that people hated it, so something smaller was extracted. So HTML was extracted from SGML and became the big popular thing that changed the world. It combined with Unix, FreeBSD, the bind DNS system, combined with HTML being served on a Apache web server, on a Linux server, using MySQL as the backup database. And the information age, and the web in particular, was born because it was enabled by the Unix or the Nix platforms. Unix for DNS, Linux for the LAMP platform. Information age born. The 70s rapidly makes way for the 80s, and proto versions come out of this through ARPANET, where the TCP protocol is layered on top of all of this. Of course, that was there before the LAMP platform, because LAMP sat on top of TCP/IP, which basically means that computers can talk to each other in a loosely decentralized way, designed to survive nuclear blasts. Whole stories here. While Al Gore did not invent the internet, he did facilitate the flow of open technologies that were in the public's interest, from ARPANET to internet, from internet to web, and from web to the modern world we know today, where so many large chunks of it are actually commercial portions from either the big telecoms like AT&T and Verizon, or from the big cloud providers like Google and Amazon and Microsoft. So you got your modern infrastructure, you got a lot of your old school, you got a lot that's possible with your old school without tapping into the modern infrastructure. You got modern infrastructure jealousy and envy by looking over at what's possible by proprietary software and tools running on proprietary modern hardware. You see the PFM, the pure effing magic that's made possible there. You have Microsoft jumping on the bandwagon and blurring the line between what is free and open source and what is proprietary with VS Code, one of the greatest modern stories. Are you one of the VS Code sheep? Yes, you are. I am too. It's just the latest editor du jour, and I'll tell you why in my series. Anything tied to user interface, human user interface, other than the row and column, generally 80 columns across by 20 to 40 characters up and down, is not old school. It is some new modern fangled platform. And those people who are familiar with X Windows saying, oh, it's already that. We had the web before the web. Why do we need all this other windowing stuff? Will tell you that everything old is new again, and there is always a human user interface platform du jour. I don't know. Maybe it'll be swipe gestures in the air interacting with superimposed augmented reality through your contact lenses or projected into your eye from your eyeglasses. Can take you off the net, but not full machine-human integration. It's very interesting. You can really blur the line between machine-human integration because studies show us you can portion off portions of our senses, touch and surface area, so you can have things against your tongue, on your palm, on a toe, that can poke you and provide almost like braille input. And over time, you'll read that as another sense. You can partition off a portion of your field of vision for that. Of course, any other sense can be used for that. Taste, potentially equilibrium. I mean, it gets really wacky. But machine-human interfaces are limitless. It will be part of the evolutionary story of humans. Some of them will be so profoundly addictive that it will branch humanity, like Linux and Unix has branched itself. Memories taken by cameras and life casting and stuff on YouTube today will all be long-term hereditary because there will be value to it, and that stuff will be passed down from to ancestors and stuff. Descendants is what I'm trying to say. And I'll probably have to wrap this video up soon because I'm coming up on an hour and I haven't taken myself offline. And when text messages come in, I start to get a little bit nervous because a phone call will stop the video because of the way the camera works on the iPhone. So here I am using a proprietary tool, even though I have the Note 8, one of the great platforms in history, right here besides me, because I might like to shoot these videos with a pause effect on the built-in camera. But I'm using my 10X Max because it's still the best right now for me and what I own. I fondled the 12 Super Max big one that went back to the hard edge around, wow. It's so interesting with how the proprietary platforms are truly becoming these magical PFM, pure effing magic platforms that even people like me who like to understand things old school and occasionally hack. I used to like to hack a fair amount in my younger days in a good, positive sense. Use hardware in ways it wasn't intended, break the hardware licensing agreements left and right, be part of the Open WRT project, because whoops, if Linksys, you made that mistake, public good, you got to give back, and now we can make repeaters that are also gateways. Gateway repeaters are a dangerous technology because they make ad hoc mesh lowercase internets possible and could someday make the uppercase internet and centralized control, impossible. And you can just learn how to build these things through a combination of cheap components that you can get off of the company that sells Raspberry Pis, Element 16. I think they have a few names, a new name now. But these component companies can be massively popular, as big as Amazon, as Alibaba, and I forget what it is, Ma, that guy who disappeared in China for a little while, the founder of Alibaba, a catalog component company, a lot like Amazon, but that resells component parts for business, can easily be as big as consumer-facing Amazon. There are mega companies other than the ones you know every day out there, and they're not American, and you're not doing business with them, and there's enough business elsewhere in the world other than you to comprise these companies. The world is different than what we think. We know the world as we do through our senses. Our senses are tools. Here we are on an hour. I'll wrap it up with some clean, sharp thoughts as a gift to those who actually made it to the end of the Ramble with Mike on his commute time. Our senses are tools that evolution or nature, call it what you like, have created. Our hands and fingers are extruded foam metal in the form of calcium, one of the ites. I always forget which, but one gets extruded to create hard external shells for clams, and one becomes the enamel of teeth, the exoskeleton or chitin of insects, and another type becomes our internal bones, and it gets extruded out like toothpaste. And something in the protein folding, blurred line between our DNA and the RNA machinery that builds things like bone extruding from foam metal parts, right? It's a thin line between the information of who we are and the machinery that builds who we are. That's what makes DNA special. It's bound in a stable-ish state, double helix twist. Big insight into nature. Stable forms take two. There's a pairing, so you're into the two world. You're not in a one world. Two pairing of bounded up, attracted to each other through magnetism, strong force, mirror image, with a twist, the same twist in DNA, that twisted pair that makes radio waves go better through old-fashioned DSL style non-fiber optics if you take braided. So even the fact that you braid your copper wire, it's twisted and then twisted again as your braided copper wire is insulated and in turn braided again to become twisted pair. And because of all this twisting, signals go better. Big insight. I don't know how much science completely understands it, but the same can be used to compress images, video, and fractal compression to make the fractal compression we know today for streaming look tiny compared to the real compression that's possible that takes place in our DNA and in our chemical memory. Quantum effects are not always necessary to tap or to call for some miraculous spooky force making all this stuff possible. It's just made possible because what we thunk down to binary electronics so often to make things easy to understand with one particular hack are so difficult to understand with twisted pair, twisted DNA hacks that create other real-world phenomenons like higher data integrity and higher data compression. Because when you uncouple that mirror image pairing, take a fragment of it and let it go loose in the protoplasm it's floating around in, it'll start grabbing onto things and folding it into stuff it needs, like bone. That's what protein folding is, and that's what RNA is in relation to DNA, and that's why even these, mRNA vaccines that came out recently to fight, the latest pandemic are so important and miracles because we engineered those with the knowledge that we have from this stuff. So instead of being in Mad Max time where gasoline is the most precious thing on earth and water being a close second, clean, pure water, we're in a world where we can hack reality using things we don't fully understand yet and not kill ourselves in the process, and to rinse and repeat, and to do that repeatedly. That can be done by the true scientists, artists of our age, who are working with miraculous effects that could change the world overnight in ways that I do believe, not in the conspiracy theory nut way, but in the mature stewards of an inevitable technology change in the world way, are doing. Anti-gravity is a matter of time. It's not if, it's when. And for anyone who thinks that's a conspiracy nut thing, and they'll probably flag my video here on YouTube a certain way, I will just present to you the fact that we have not unified it with the other forces. There is an elusive, not yet understood mystery, no matter the hubris of science of wanting to say everything will be figured out. We don't know how to manipulate gravity with a hack or a trick yet in the public domain, public knowledge. We do know how to do it without a hack or a trick. You just start condensing stuff together and it will exert a stronger gravity field. At the center of the earth are metals and the heavy elements packed so profoundly tightly together that if you were to take a teaspoon of this stuff, take it back up here on the surface, one, it would probably expand to some other, state of matter. It's probably in some metamaterial state in the center of the earth, and it would probably expand and become much larger as it cools and its atoms achieve more of a random state, even as a metal. We have things such as super liquids, and I'm sure metals have sort of their equivalent. There is a metal form of hydrogen, for example. So when hydrogen gets down to 0 degrees Kelvin and the atoms are packed as close together as they can be, you've got some sort of metamaterial with meta properties that we probably don't know a heck of a lot about. And how different is that really from a metamaterial of iron at that point too, with a different atomic weight because of the number of protons in it. And neutrons, I guess, make up its weight. The number is the number of protons. I think it's 23. But when you take hydrogen and you pack its atoms so close and tightly together into one of those metamaterials, if it radiates off its neutrons, it can be considered hydrogen. If it still has neutrons in it at a certain neutron to proton ratio, I guess it would be considered a metamaterial of iron, 23 to 1, or something like that. I forget. No, not 23 to 1. That'd be something different. But 1 proton for every. I forget how the 23 would fit in, but definitely alternating like a checkerboard between protons and neutrons would be more of a traditional metal that we know. And okay, anyway, I diverse. Point is, lots of thought experiments are possible, and it's exactly these thought experiments that move forward the state of science, and I would argue art too, because there's always a vibrating edge where these tests are actually able to be carried out. And sometimes it can be done with a human scale macro hack, like the two slits experiment, the famous 2 splits experiment that reveals the particle wave duality nature of light particles. And later we come to learn that even things like buckyballs, carbon atoms that are bound together in a in a circular soccer ball-like shape, so that they don't interact with anything else but themselves. It's another metamaterial. It would be super slippery. There's no bonds. So there's no friction if you had a teaspoon of buckyballs. It would appear like some sort of liquid. It would have a weight to it, but it would be like a powder with no friction. So there's always some scientist and apparatus somewhere who really, really can experiment around with these things, and that's science, and learn things for the first time, and make guesses and make hypotheses and do physical experiments. I remember some studies when we learned that about turbulence, where we were doing it in liquids contained in microcylinders whose rotation was controlled at such small scales that we could learn what was going on in turbulence at those microscopic levels, so that we could continue developing chaos theory and understand that no matter how much determinism in a Newtonian clockwork universe might be true, the actual complexity going on in our world because of turbulence and things like it make it such that for all intents and purposes you cannot think of determinism as being true, because you can never have initial conditions, because the world is so much more complex and nuanced than anyone can even imagine, because as many atoms are in a grain of sand, there's that many light particles or particles of energy inside an atom. There are nested universes of particles because E equals mc squared, so the corollary, every bit of matter is made up of something like a quantifiable amount of energy, particles, photons, smallest possible photons, perhaps a 1 Kelvin large photon of light that somehow still has properties that does not reduce it to a pixel or binary like thing. There is still ultimate variability, infinite variability within even a single light particle. So perhaps within light particles you have that elusive string or vibrations or vibes or essential essences that can be carried around in something as small as a single photon, 1 Kelvin large, smallest wavelength of light particle. So these thought experiments are possible even for people who are non-scientists such as me. What am I? I'm a Python programmer. I used to be a search engine optimizer. I suppose I can and still should call myself that because that's how I make my money. These concepts are elusive. The way the world really works is very, very elusive, because describing it, interacting with it, expressing yourself is so often reduced down into language. It's encoded. It's encoded into language. Speaking, communicating yourself, expressing yourself, and certainly doing it in such a way that automation can occur as a result of your self-expression is all a function of language. Language is a tool. It is a contrived, somewhat arbitrary, highly evolved, external, but able to be thought of as internalized tool. It's internalized because you learn a language as you grow up. It's external because you have to learn it. It's internal because the capacity or predisposition to learn spoken and written languages is already in you. Were you not taught English or Chinese or, I should say Manchurian, because there's so many types of Chinese, there would have been some other language that would have spontaneously occurred or been developed in you as a result of, we know, twins making their gobbledygook twin talk, secret languages. Language is just a function of sentience, of thought, cognitive reasoning, being able to observe the world through a sufficient number of senses and having the ability to manipulate the world through appendages that are often closely intertwined with those appendages, sense of touch on fingers, sense of taste on the tongue. Eyes and ears work a little bit differently. There's certainly body parts, if not appendages, tied to them. But the concepts of interacting with the world, of being mobile, of manipulating the world, and the sensory equipment that lets you see what's in the world in the first place are closely intertwined and intermixed, and defines a lot of who we are. Now, there's internal bits that become difficult to talk about as organisms become larger and look more like life, that look more like simple chemical reactions, which would be organic molecules, things generally made up of carbon, because they're the ultimate vibrating edge of elements. I believe they are 6 on the, they're either 6 or 8, I forget. Oxygen, I get oxygen and carbon, but they have half their valence electrons available to contribute to a reaction, and half their valence electrons held close by its internal parts that cannot be given away. So that's why things like buckyballs that take on this soccer ball shape are possible with carbon. The vibrating edge nature of carbon lets it create all these wonderful Lego-like structures. The circular buckyball or soccer ball, which would be a sort of powder. The carbon nanotubes, which if twisted in the twisted pair trick that we talk about, could become fibers that could hang space elevators that strong. First you twist it like the twisted pair of the inside of things, of copper wire inside old-fashioned telephone twisted pair. Then you take that and you insulate it and you twist it again in the larger twisted pair that actually runs through a lot of our walls. You can take that tiny twisted pair and twist it again with a larger cable and deliver something a lot like DSL, or you can get rid of all the twisting and go to fiber optics that has no twist right now yet, and have much higher bandwidth with no twist. Find ways to twist your light inside the fiber optics and your densities will go up by an order of magnitude again. And everything that we know today as so profoundly magical and high bandwidth and low energy consuming and low money cost will be 100 times simpler than the new things that are possible at the keeping pace with Moore's law, equally cheap, equally consumer oriented, equally reliable as today's consumer hardware, which is a remarkable thing that today's consumer hardware can be as complex as it is and still as generally stable. I say generally stable because it does not perform to a specification of other things do, which is often inherent in the languages and the tools, which is why a lot of people in the financial industry are still in Java. They're still on some things running COBOL on their old PDP-11s that they don't even want to trust to emulators for fear of bugs getting in through emulators. The less surface area, the less moving parts, the better for some applications. That's where ASICs or, custom hardware, they even have custom hardware to do Bitcoin mining and stuff. When you have a task that's in mind that you can control your hardware for, reduce the surface area, custom produce it, you reduce overall cost, you get the bugs out. That's what Apple did recently with the ARM64 that we've come to know as the M1. That Microsoft is jumping on the bandwagon. Fewer parts is generally better, lower power consumption. Specialized instructions and more complex hardware can be built in for optimized conditions in special cases. It's good for certain game hardware, GPUs to render out the triangles for better, user experiences. Often becomes tied to platforms du jour. Platform du jours are great. Vendors will make a lot of money off of you. The tools will be better than the free and open source equivalents. the vendors will try and make you think that those tools are the free and open source equivalents of VS Code. I'll teach you why. Yeah, you should take take up power tools from time to time, but you should always have old school in your back pocket. And that old school is really mostly Linux, Python, Vim, and Git, with an honorary shout out to JavaScript, because you should do something that you can call close to mastering platforms du jour. Just know that sudden liquefaction is going to occur underneath of you. Even the web as a platform, the web as a sub-platform, as the other platform it's living on. No matter who wants to talk about the full web stack is the last, JavaScript programming language you'll ever need, because all the levels of the stack run JavaScript. It is still an embedded language made for a particular problem, use case, that happened to explode into something much broader. And people who are forced to view the world forever forward through the lens of JavaScript because of Node and the full web stack, I would propose to you that you are missing something that is highly useful on a day-to-day basis, that your primary way of operating, your 80-20 rule, your sweet spot, the way that most of your work should be most of the time, so it can be mastered, so that it can fade into the background, so that you never have to think about the language as an external tool again, so that it can be internalized like the bones and the English language and the things that compromise your internals that you rarely think about. Your internal respiratory and heartbeat regulation system, you don't think about these things. I tell you that Python is closer to that than JavaScript. It's closer to that because it did not make a lot of concessions for the C lineage that likes a lot of semicolons and curly brackets because of compiler requirements. If you want that in your life and you want the true benefit of that, go to the Go language and get the advantages of parallelism, and think about parallelism while you code. If you want the advantages of the sexiest consumer-oriented platform du jour to make the most money in the latest Instagram jackpots of making the latest app to be successful in the app stores, and do a lot of mobile development and a lot of development of things that can transfer between things on the pseudo sub-platform of the web, then do JavaScript. Job security will make a lot of money. If you want to change the way you think in your head so that you become more machine-like, like the Mentat from Dune, if you want to be able to process lists naturally and just inherently know the difference between mutable dynamic lists that make you that can allow you to do everything at the expense of optimization and becomes difficult to compile, use lists if you know the shapes that those lists are going to be and you want to give them nice labels so that things can be referred to as a name for a position in a controlled length list, then use named tuples, named tuples. Use named tuples. You can use tuples, but if you use named tuples, you'll be even happier because you can use them as compounds primary keys in object shapes that look a lot like SQL unique constraints or compounds primary key data structures. And then you can use a real SQL without using the SQL syntax by working through SQLDict, using the SQLDict package that makes your Python objects, which are basically JSON objects on steroids, because they're not just JSON, they're JSON plus everything else that Python lets you do with objects, which is pretty neat. Dynamic data structures, use lists because they're mutable, they can change, they are not immutable. If you want immutable lists and data structures that have named positions, you use named tuples, tuples, apples, and oranges. No potatoes and potatoes. If you want a dictionary, or if you want a JSON-like object, what you're familiar with thinking of as JSON, you use a dict, D-I-C-T, a Python dictionary. These things are usually persistent in memory only as long as your code is running. If you use Jupyter Notebook, that's in your web browser. If you use Python through your web browser, through Jupyter Notebook, through the Anaconda install, through your web browser, which is on your operating system, which is through Windows 10 or the Mac, which is through these other virtualization layers that I talked about earlier in this code, which is through machine instruction sets that are X86 or ARM in nature, that are through your proprietary platform that you happen to have, your laptop, your iPad, whatever it is. Through all that, what is it? I forget what I'm even saying. You're expressing yourself in Python. Now you start to get used to all these thought patterns, these design patterns, though no one outside of Python would ever call it the design pattern. Design pattern is generally a word that belongs to the Java world, where they have all these design patterns that make up for the fact it's not Python. I could go into great detail, but things like factory classes and stuff just aren't even needed in Python. Python has thought these things through at the early level, and instead of being one of the arbitrary self-referential meta languages, which I was telling you, JavaScript is more in the tradition of Lisp. If you like self-referential meta languages that are very customized to a problem domain, like imperative languages tend to be, like HTML, like SQL, then you also tend to like JavaScript, because it does come off like one of these Lisp lineage meta languages, sub-languages, imperative sub-languages, oftentimes made to embed into something else, which is exactly where JavaScript came from by, I really should learn the guy's name, Heinrich, who embedded it into the original Netscape, because Netscape needed an original embedded language, you see. And that's got turned into a standard from a European standards organization. That's why JavaScript is also called EMCA, I believe it is, ECMA, European standards. But it's the same thing as, Python being a free and open source standard, and so many other languages that are traditionally embedded into other languages, because you want something that is just a free and open source, not very license encumbered specification. And they grabbed one that had syntax similar to C, because everyone knew C, and that is the reason for so many things now in JavaScript. So if you want to live with that as your primary native thinking language, all the things that they did in support of, and then ultimately in resignment to a tradition of compilers. Curly brackets are for compilers. So if you want to be bound to all the realities that had to be there for compilers, you use JavaScript arbitrarily, or you use the Go language for real reasons, because they enforce where you put your curly brackets, and they get the benefits of it in fast compiling of a massively parallelizable, creating binaries special for your hardware situation. It's still an edge case. It is not the common thing people do with computers. Google does this in the creation of systems. It's systems software. It's back-end operational infrastructure, stability, easy deployment, taking advantage of every bit you can squeeze out of your hardware at the individual level, so parallelizable CPUs within a single node, and to take advantage of your entire network, so able to communicate with each other as nodes in a neural network, in a farm, in a server farm. So all these things come together to make Go language a hot rising language. Rust, I think, is also in this arena, to a lesser degree. Haskell and other functional languages, because of their zero side effects. You don't want to marshal the side effects along all the nodes in your network, so the more functional you work, the more parallelizable your code is, and the more map reducible. It's a lot like Hadoop stuff, but more modern. And I don't think in parallelizable terms very easily. I think in sequential terms. I am a procedural type thinker. Another reason for Python, for me, personal decision. A lot of people disagree. When you deliberately control the concurrency of your code, you can do truly miraculous things, like the types of system, global infrastructure system software Google has to do. They recruited the creator of Unix itself, Ken Thompson, to do this. They also recruited, I forget his first name, but his last name is Pike, who does a lot of the Unix file system and operating system stuff. Actually, it might be Linux, I forget, but an early Unix journaling stuff, you know, a real file system guy in the tradition of Linus Torvalds himself. So they didn't get Linus Torvalds to work on the Go language, but they got the creator of Unix and one of his file system cohorts to do the Go language. And it's Google that's funding this, and it's running Google today, so it obviously worked. And these people are people who were originally in love with Python, but because of their problem domain, because of the uniqueness of their problem domain, and the extremely tight control that a foundation like Python exerts over its language, even in the face of commercial interests like Google created its own language. Pulled out all stops in doing it. You should do it. You should do the Go language when the time comes that you need its benefits, just like you should use JavaScript when the time comes that you need to eke the best performance out of all the embedded web platforms of the world. And I'm going to be doing it for Chrome automation. Indeed, I am doing it. I'm regularly doing it. It's my day job. Chrome automation, I deal with it like it's an external language that I'm controlling from Python, because I natively think in Python. So if you first think in Python, you can handle everything else as a sub-job of that, because you can invoke other languages from Python by using the way Python calls external programs using the Linux API, that is through a command line. So you learn to program in any language like you're making command line commands, and suddenly your JavaScript program, or whatever other language you choose, is a command line program that can be controlled from and invoked by and scheduled by Python, you see. So then what puts Python in control in the first place? It's knowing enough about Linux to give Python control in the first place. It's not a completely Python story I peddle here. It's a Linux, Python, Vim, and Git story I peddle here. And I talked very little about Vim and Git in this particular video, but I certainly did allude to it in the vendor trap program Microsoft is inevitably playing. Because in the game of legitimizing your proprietary stuff, make your proprietary stuff is better because it's more free and open source, you see, than the other guy's proprietary stuff. So what goes on is an embrace and displace that you saw Microsoft do when they tried to embrace and displace Java using J and J++, and Sun Microsystems actually won a lawsuit against Microsoft at that time that if they created a implementation that claims to be against an open source specification and call it an implementation of that specification, then they have to implement it properly to the specification, or they have to market it as something else, that it's not Microsoft's version of Java. It's not compatible with Java. They have infected and embraced and displaced the language of Java, so they had to go to F# instead of J++. A whole big story there. Microsoft had a pivot, and not many people did this against Microsoft. Intuit is another company that staved off the Microsoft embrace and displace approach. And we see it today with VS Code being free and open source, and the notebook environment that everyone loves, that's revolutionizing coding for the data scientists, being just a mode of VS Code. VS Code now works just like Jupyter Notebook, so you don't have to use Jupyter Notebooks. If you want this advantage, you use VS Code. In fact, we save as .py files that are cleaner in Git repositories and GitHub. So Microsoft bought GitHub several years ago, the heart and soul, the epicenter, the rallying point of the free and open source community. It completely took over from SourceForge and Freshmeat and other sites like it that used to serve that function in the past. So Microsoft owns GitHub. Microsoft hired Guido van Rossum, the creator of Python. See? Embrace and displace is taking place in full gear. They've done it to Jupyter Notebooks. Microsoft also offers cloud-based notebooks on Azure, so that you start out with notebooks on Azure, their cloud platform, instead of on sorry, just don't mind me. I'm finding a different way. I have to be a little later to where I'm going than I normally am. So I'm just killing time on the drive here, and I don't want to experiment too much with different ways or get myself in trouble by being too late. But I saw in the text that popped up, I got to be a half hour later than I was expecting. So you get the benefit of even more rambling. It's at 1 hour and 40 minutes. I said I was going to stop at an hour, but this is such good stuff. Let me wrap up and put a sharp finish on these very abstract concepts that I want to hit home, around which I rally my online content, around which I'm trying to make my specialty, because there are so many vendor traps people fall into. So one of my purposes is to show you to think about it properly. While falling into a vendor trap, maintain this old school way of doing things on the side and in your back pocket, and focus on mastery, the muscle memory mastery way of doing things, so that you commit this to non-thought, so that you can use the Vim text editor to produce Python code or text of any other sort, because controlling tech is controlling text. When you want to step in and take control of a Linux system booting up, you're editing configuration files under systemd that I'll get you familiar with, and just by naming them a certain way, according to a certain protocol and standard and syntax, by naming them a certain way and then referring to those names with other files that exist at certain places, you get your software, your Python software, to auto start when the system starts up with the correct run levels, with the correct permissions and securities, and all the things that the operating system poses to take care of you. A lot of controversy in that around systemd, but it's still the cleanest, easiest, best way to do it if you don't want to become a total Linux head writing bash scripts in Unix script, writing Unix bash scripts to start and stop your services and every little thing you might need to do with your service. Instead, you use a standard that creates some dependencies, that wraps a few things together as a bundle, having to do with login and permissions, and it's an okay compromise to make to get the power I kind of propose to get. I'm in the systemd camp and not in the initd camp of Gentoo and Slackware. I'm in the systemd camp of Red Hat and Ubuntu and Debian. So at any rate, that's a good place to wrap up here. You got to learn to think in these languages. They get into your mind, they get into your fingers, they become something of a first-class citizen in your head, and the filter through which you think about and attack all other problems in your mind, at your job, ultimately in your life. Gives you greater ability to automate small tasks, to tap off small tasks in an ad hoc fashion, to have interactive work sessions with other people, to let other people get on board into this strange encoding your thought in the sorcerer's apprentice that makes things happen sort of way, the accessible way of Jupyter notebooks and data scientists, the less accessible but ultimately more powerful and worth it way of systemd background daemons on a Linux system so that you can schedule and make this happen 24/7 reliably, and then how to scale that, slam out 1,000 instances of that if you need it in order to oh, I stay on this road, my bad. Make sure this person knows I'm staying straight. They do. Okay. You slam out thousands of instances of it and know how to learn the next skill set, the next nuance, the next thing to master, which is through tools like Ansible, or you can just cobble together your own scripts from Git, but it's the same issue. There's lots of tools out there that let you manage hundreds or thousands of instances of what you built that works on that single old school headless, almost like a web head. If it were web technologies, we would call these web heads, but we need something else for you might schedule it or do something else along those lines in order to make your code run under unlimited context. You're not tied to machine or platform or vendor. It's just a complete generic, free and open source, plumbing of tech way of doing things that is also simultaneously love-worthy. Talk to anyone who does things in Python mostly, and they'll tell you how love-worthy it is. There's other parts of it, but they come across more as like the necessary evils. Learning enough Unix script and the custom format of systemd in order to get your stuff running in the first place in the background, and the testing stuff, making sure it's running, heartbeat monitoring. There's a lot that becomes I guess I would call it tedious, except you grin and bear it, just like the JavaScript portion, just like the regex portion. There's always bits you gotta hold your nose and do, because it's a sub-language that was made with that whole Lisp mentality to make the best sub-language for that problem domain. And so you live with the problems of that, sub-language for that problem domain, knowing you'd rather be doing it in Python, but because the world the way it is, you're forced to do it in this sub-language. Sometimes there's a wrapper, but in the case of Chrome automation, the wrapper is Py-Patir, which makes you deal with all the concurrency issues of JavaScript. So if you're going to deal with JavaScript concurrency issues with the await sync keywords, async await keywords, you might as well just directly be using JavaScript and jump on the bandwagon, even if it's not as a full web stack developer, which is why most people jump on the JavaScript bandwagon, or to use the full web, or to be a UX, a user experience and user interface developer with like React or Vue.js. That's another big reason. But I don't like that whole de jour thing, and I like technologies that cut across time and problem domains, that I can think very naturally in, that are not so condescending as to be inaccessible to the noob. I like languages that are inviting and say, hey, people of normal cognitive reasoning levels in everyday life have not gone this fantastic route of being the maker of tools. Guido and Linus are at a completely different level. But if you want to be a master craftsman and express yourself super well using the tools that these other tool creators have used, and become a master user of tools in a way that's always relevant, where you're always a seat at the table and it's fun work to do, then Linux, Python, Vim, and Git, and the route I'm advising you to take here. So there it is, an hour and 3/4. It's probably my longest video ever. I'm gonna love uploading this to YouTube. I'm gonna check what that text says, and I'm either 8 minutes late or 20 minutes early. Thanks for joining me. Hope to see you all again soon. Don't forget to subscribe, and I promise in the future I'll do edited together quick synapses so you can get the benefit without the 2-hour lecture. Thanks for joining me. See you again soon. Bye-bye.